Hi everyone, my name is Armando Melgarejo and I'm a technical service engineer at Park Systems. I hope so far you have been enjoying this year's NanoScientific Symposium. And well, today I'm going to show you a demonstration on a Park NX10, and we will be talking about SmartLitho Nanolithography. For those of you who have never heard the word SmartLitho before, well, SmartLitho is Park Systems' new nanolithography software, which allows you to do nanolithography and nanomanipulation with just a few clicks. SmartLitho has the SmartScan interface, therefore it has a very friendly interface, especially for new users. And also comes with the advantage of a standalone designer, which will allow you to design all your nanolithography and nanomanipulation process without the need to be sitting in front of your IFM. You can design all of this from your computer or from your office. Well, before going directly to the demonstration, I'm going to tell you a brief introduction about what is nanolithography operation. Commonly, we divide nanolithography into force-assisted and bias-assisted. As the word said, force-assisted depends on the amount of force that I'm applying to create these fine groups, and the bias-assisted, it depends on the amount of voltage that I'm going to apply to create anodic oxidation. But in the SmartLitho, we're going to classify our operation into three processes. First one, it's called scanner mode, C-scanner mode, which depends on maintaining a constant depth or constant height. This is very useful for nanomanipulation. We also have set point, which the main difference between the first one and the second one is that the second one you control the amount of force you're going to be applying to the sample. And the last one, it's bias mode, which depends on the amount of voltage you're going to be applying to create the oxide patterns. If you look above me on your left side, you will see there are some examples of anodic oxidation over a silicon wafer. With no further introduction, I will go directly to the operational demonstration. I will first start with the pre-scan image. As for lithography processes, we first have to verify that where we're going to do our lithography process, it's a good spot over my sample. So in this case, I have already selected the spot that I desire. I will just right now activate my line scan to see if the trace and retrace signal are good. I'm seeing that everything is okay. So if you can see, I'm using 13.9 nanometers as set point. I'm scanning at 1 Hz speed, and I'm using 0.7 for the C-circle gain. Both of them, positive and negative. If you look at the mode that I'm using non-contact mode. The only reason for this is that I want to preserve the lifetime of my cantilever. Therefore, that's why I'm using non-contact mode. Also, this is a compact disc, so it's a polycarbonate film, which is very delicate to stiff or medium stiff cantilevers. In this case, I'm using an ACHR cantilever. Therefore, if I try to scan with this cantilever, I'm probably going to scratch on my surface of the sample. So my other option will be to use a softer cantilever to scan this image. But as I actually want to do scratch over my sample, that's why I'm also using non-contact mode. If I look at the topography, we can see we're going from a couple of angstroms to maximum 2 nanometers with a relatively very smooth surface. So once we're done, we just have to lift from the sample, and we lift from the sample with the activate line scan, and we change to contact mode. The reason we're going to be doing this is that our SmartLitho software works with contact mode. If you, for some reason, forget to change to contact mode, don't worry. When you go to SmartLitho, it will automatically tell you that you're in non-contact mode, and before starting the lithography process, it will make you change to contact mode. We have already changed the sample. We're reapproaching the sample, and then we can go directly to the lithography option. If you look again above me, you will see that in between the scan and the spectroscopy window, there's a new option called lithography window. Litho window, which is the lithography. If you click there, we automatically activate SmartLitho software. Once in there, you just gotta first select the mode you're going to be using. As I mentioned before, here we have set point, C-scanner, and bias mode. In this case, I'm selecting set point, and then I'm going to the options panel. In options, you can control the speed which you're going to move around the sample when you are not drawing. You can also select the height at which you're going to lift from the sample when moving from one feature to another. and some other stuff like the settling time, either from the Z movement or the XY movement. When you're done with this, if you look at the right side of the panel of the screen, you will see that there's a panel called Object Edit. In there, you can first select the speed at which you're going to draw your features. In this case, we're using 0.5 for all the features we're putting in there. And then we have CN at the start, set point N at the start, and bias N at the start. In this case, as I selected set point, the only one that I care about is the set point. You can see that we can actually apply different amount of force or different amount of set points from the end to the start, and we'll create a rampage if we do this. If we just input the same value as I'm doing here, you will have a constant force around across all your process. So in this case, I'm applying 100 nanonewtons to the column on the left, 200 nanonewtons on the center column, and 300 nanonewtons to the right. Once we are done with adjusting this setting, you have to click Start, and the lithography process will start automatically. We can see that it just takes a couple of seconds to actually finish the lithography process. If we look at the upper right corner of the screen, we'll see that there's another panel called Object List. This object list will give us an estimated time of how long will take our lithography process for each feature. Once we're done, we can go back to the scan window, and now we're going to do the post-scan image. This is just to verify that we have actually created our lithography features. So one more time, we just have to change the mode. We're going back to non-contact mode. As you know, whenever changing to non-contact mode, the software performs an automatic frequency sweep. This is just to verify that our cantilever is in good shape and it's functional. You can see right now that this is not a new cantilever, but it's going to work for our purposes right now. I'm going to select 10 nanometers amplitude, and once we're done, I can just close this window and go directly to my scan window. And there I can just adjust the settings. I'm going to be using the same settings that I was using before in the pre-scan image, although I first have to approach. Okay, now we're approaching. We'll see that the software takes just a couple of seconds. It's doing intermittent approach. It's being careful to not damage our pigment or our sample. Once we have approached, then we can activate the line scan to see if the trace and retrace signal are good, to see if we need to change something else. We see that they're pretty good. They have pretty good alignment. But just to make this comparable with the previous image we have, we're going to use the same settings. So 13.9 nanometers as a set point and 0.7 for the C-servo gain for both of them. And when we're ready, we just have to go back to the scan button and just click on it, and we'll start scanning. Right now, we just have to wait a couple of seconds to start seeing our created feature, our fine groups. As you remember, the lower row was there were 3 lines. The middle one were squares, and the upper one were circles. Right now, we can start seeing the lines. We can see that from left to right, the left one, it's a little bit more blurry. This is because we just apply 100 nanonewtons, and the ones in the center and the right are more clear because we apply a bigger amount of force. Right now, we should start seeing the squares. If we look at the topography channel and the signal we insert the cursors, but they are not landed exactly on the groups we created. But we can actually see the groups that were created, because we can also see an increase in the topography. Whenever we created a group, the film around it got accumulated and created bigger difference in topography around these groups. And we can clearly see the squares. It has the same phenomenon as the lines. The left one is not as clear as the right one, but it's because of the amount of force we have just applied. And we can finally start seeing the circles in there. You can also see the 6 groups that are formed around 6 because there are 2 per circle, right? And we just have to finish a couple of seconds before we can proceed to analyze our image in what we know it's our analysis software, which is called XCI. So the scan is done. We can now go to Part XCI software. And once we're in there, we can analyze our topography data. We can go to line option, and in there we can use haste color to distinguish better the feature we have just created. And then we can insert an average line, an average horizontal line, and we can measure the width of these groups we have just created. If we start the first cursor, we can see that the average of this first one, it's around 40 nanometers. The second one, it's almost 50 nanometers, like 49 nanometers. And the last one, it's around 58 nanometers. So we can see there's a correlation between the amount of force that we're applying and the width of these new groups that have been created over my surface. And finally, if we want more information about our topography, we can go to the 3D option and we can create a 3D render of our image. And here we can analyze the features. We can clearly see the difference in height that were created in the size of my groups or the depth of my group, depending on what I want. Well, thank you everyone for your time. I hope you have enjoyed this demonstration. And if you have any questions, we will now proceed to a Q&A session. So feel free to ask any doubt. Thank you.